In this video, we pay attention to monotonicity of a function by providing example. We have this function f of x, which is the natural logarithm, and here inside the parentheses we have x to the power of 4 plus 1. The domain of the function is the whole set of real numbers. It is a continuous function. You have x to the power of 4 plus 1 is a sum of two continuous functions. The natural of logarithm of this, when you have a continuous function, is also a continuous function. So we take the derivative of f. 1 over x to the power of 4 plus 1, x to the 4 plus 1 derivative 4x cubed divided by x to the power of 4 plus 1. Now I take this derivative equal to 0, and from here I get that x is equal to 0. Now I want to see the values for which the derivative is positive, for which values of x. So I need to solve this inequality. And here, of course, the term in the numerator should be strictly positive. So x should be greater than 0. F prime of x strictly less than 0. This is achieved when the values of x are strictly below 0. We also consider what happens to the boundary of the set. So we take the limit of the function as x grows to infinity, to plus infinity. And this goes to infinity. Also, as x goes to minus infinity, we take this limit, and this goes to infinity. Now let's make a table. We put x, f prime of x, and f of x here, and then we put the values here, minus infinity, the real line, and here the derivative becomes 0 at 0. So if x is greater than 0, the derivative is positive, and if x is less than 0, the derivative is a negative function. So here we draw an arrow that goes down, and here we draw the arrow that goes up. Negative derivative means that f is monotonically decreasing. Positive derivative, f is monotonically increasing function. Let's call this interval delta 1, and this one delta 2. Delta 1 is the interval minus infinity to 0, and delta 2 is the interval 0 infinity. So the function f is monotonically decreasing for every x belonging to the set delta 1, and f is monotonically increasing for every x belonging to delta 2. So it's going down and then it's going up, so we have a local minimum not f of naught. What is f of naught? We can do a calculation. F of naught is equal to 0. So the local minimum is attained at 0.0, which is the origin.